Veronica catches the bus each day on her way to work. A bus arrives at her stop every 10 minutes, so the probability distribution is uniform. So what we have is a continuous uniform or rectangular distribution. And she could arrive at the stop just as the bus arrives, so that would be 0. And every 10 minutes, so the longest you'll have to wait is 10. We want to find the probability that on any given day she waits less than 5.5 minutes. Well, we know this gap is 10, so the height of the rectangle must be 1/10, so that the area is 1. 5.5 is here, so we want this area here. So that's going to be 5.5 divided by 10, which is 0.55. If she catches the bus for a week morning, Monday to Friday, find the probability that her average waiting time is less than 5.5 minutes. Well, we just worked out the probability of it being less than 5.5 in part A of the question. That was 0.55. This distribution is symmetric, so if it goes from 0 to 10, we know the mean is 5. So we can say that the population mean, which is always called mu, is 5, and the population standard deviation, well, you probably won't be expected to work this out, but sigma is always b minus a over root 12. So here that's 10 take away 0 over root 12. And if we calculate that, let's just do that quickly. So we've got 10 divided by the square root, put the square root on top accidentally. So I need it to be on the bottom. Square root of 12. So that's 2.8868. So 2.8868. And we're doing it for 5 days. So we can say that n is equal to 5. So the sample mean, as discussed, will always be equal to the population mean. The sample standard deviation is going to be the population standard deviation divided by the square root of n, which in this case is 5. So we just need to work that out. So this was our answer to the last part. Just drag it down there, and we'll divide that by the square root of 5. And that gives us 1.291. That's as much as I'll write down at this stage. So if we consider that y is a normal distribution with mean 5 and standard deviation 1.291. So the parameter here needs to be 1.291 squared, and we're after the probability of y being less than or equal to 5.5. Then we can go to our normal distribution. So normal CDF, and it's a normal distribution, so we need to go all the way down to the bottom, negative infinity, up to 5.5, and sigma was the 1.291, and the mean was 5, and that gives us 0.6507. If she catches the bus for a whole year, 200 working days, find the probability that her average waiting time is less than 5.5 minutes. Now we'd expect a much larger probability here, because when we work out the sample standard deviation, we're going to do the 2.8868 over root 200. Now this makes sense if you just think about it. On a small sample like 5 days, there's a good chance that even with an average of 5, that we'll end up with a few buses up in this sort of region. But over 200 days, we'd expect to be much closer to the average of 5. So let's see what happens when we actually calculate it. So what I'm going to do, I'm just going to go back and edit this one. So I'd like this 5 here to be 200. And that gives me 0.2041. All the other things, note, are the same except the n. The n's now 200, which we used here. And so when we come to here, what's changed? So negative infinity to 5.5. We know the mean was still 5, but we just need to change our standard deviation. That's going to be 0.2041. Execute that, 0.9929. So that's the probability that y is less than or equal to 5.5 was 0.9929, where y, of course, this time was a normal 5 because that was the mean, but 0.2041 squared.